Welcome everyone. I think this is a very great day to join the OCP technical weekend, and I hope everybody can have a wonderful day for you. So today I'm Gavin Wang from Inspur. So I'm in charge of the Inspur's OAI Reference System design. So today I'm glad to introduce the Inspur, so OEM reference system to you. So as we know, the OAI is a group mainly focused on the open acceleration the technology, and Inspur, we as a system vendor, we working very close in this group. So in this group, first, we just participate for the OEM, the spec design, and also we just lead the UVB, the spec, and also the UVB, the board design. So the first thing is we based on the UVB, we just built the Inspur, the 21-inch, the OEM reference design. So in the left page, you can see the last year, the OCP, the CTO build cutter, just so Inspur the UVB in the Amsterdam the summit. And why we focus on the reference design, so we just want to provide unique and based on the OCP spec reference system, we can let all the vendor to use as a reference design. We can lower some enter lower difficulty to the design, and let most OEM vendor can use this for your based on your different scenario. So you can use this platform to focus on your design. So you see in the left side, this is our based on the 21-inch OEM reference system. It's both on the old front access design. It's very convenient for the data center to maintain it. So in the front side, you can see in the middle side, this is our the OEM module. We can support the 8 OEM module in the middle. And in the other side, in the bottom side, we just reserve some the high density connector. So each connector we can support 2x16 LAN. We can also support multi-host. So in there, we just provide a very flexible architecture, so we can let a customer to connect different number of the compute node. So they can automatic to allocate their workload based on their different AI scenario. And also in the upper side, in the each side, you can see there, we just reserve some 2 IO module. So each module we can provide 2x16 the standard PCI law. So we can also provide a very flexible the expansion capability. So you can add your, for example, you can add some the NVMe drive in there to do some the data acceleration, or you can install your special your devices in there. So this is a very flexible design for the customer. This is our OAI system feature. The full factor is based on the 3OU. It's a very high density design. In the 3OU, we can support the 8 pieces OEM. We can support both the 48 wall, and also we can also support the 25 wall. And all the current version we based on the PCI Gen 4. So just I mentioned, we also provide a lot of the PCI expansion in the front. We can provide very flexible and convenient expansion for the customer side. This is our system placement overview. So all the design is about the modular design. Yeah, you can imagine, you can very convenient to change each component as soon as possible. So it's very easy for your convenient. As middle is the we call the UVB, and in the each other side is our PCI module. In the front, this is front IO. Yeah, we can provide the dedicated management port for your remote management. So in the real side, so we use because our design is very high density. So we just use two board connect together their design. So in the upper side is our switch board. In the bottom side is our power distribution board. This is our system topology. So we just use 4 PCI switch. So each switch downlink we can support 2 OEM, and each OEM we can support dedicated expansion the QSBDD. You can use this port to do some scale out. So for the uplink, so each switch, the uplink is we provide 1/16. So you can use this link to provide to connect your the compute node, yeah, to just combine the total solution based on your workflow. And also I said from the switch, and also we can provide totally 4/16 in the front side. So you can add your some PCIe slot card to do some your application expansion. So also just aside, our this is reference design is very flexible. So we can support multi-host topology. So you can based on your workload to allocate the different compute resources. So this is the left side is that it is the show we can support 2 hosts. The right side is you can install the full socket based on your workload. So this is our Inspur, the UVB design. We just follow the nearest spec. So current design we mainly focus on the fully connected topology, and also we have use some the lower pole. We can also build the small Hooper mesh the topology both. So this is our the system power distribution the design idea. So the input in the real side we just directly use the 54 volt because we just want to enhance the power deliver the efficiency. And in the power distribution board, we just separate the 45 volt to the 45 and 12 volt. Then, so for the UVB side, then we can both support the 2 different voltage of the OEM. We just provide a very flexible the power distribution board solution. We can support the different OEM solution. Besides reference system, also Inspur, we working on the rack level OEM solution. This is our rack level solution. We based on the 48 volt old rack solution. It includes power shelf, switch, and our OEM system, and Inspur based on the OCP spec the compute node. So we can provide the total rack solution for the end user and customer. So this is our high level rack level scaling topology. So in the left side, this is our Inspur compute node. So we can use the retimer card to connect to our MS1, the OEM reference design, and we can use the UVB, the external QSOP, the connector to scale out to connect to other different our OEM system. We can just quickly to build the AI cluster. So based on the customer different the scenario and the workload. It's very very flexible and convenient to scaling up the customer cluster level. And this picture we saw, this is our minimum the total solution. In the left side is our San Jose compute we already submit to OCP. So you see this is our OEM system. Yeah, this is we just use the high density connector and cable solution. We just connect our compute node and to our OEM system. Yeah, this system is ready. So also we willing to join some the customer, do some the POC testing. So this is some we latest our the system and some spec you can find in the OCP organization website. So thank you everyone. This is all I have today. Enjoy yourself in today.
Great. Thank you so much, Gavin. Really appreciate that presentation. And also thank you for getting us back on schedule. Appreciate that as well. Let's see. Are there any questions in the chat for Gavin? All right. And folks, as a reminder, if you would like to ask a question, you can do so in the comment section to the right of the video player, or feel free to hop on the Zoom and ask a question that way as well. All right, if there are no further questions, I think we can probably go ahead and